reservations in two-way slabs by means of yield lines. Consider a slab when one side has a fixed end and the others are simply supported. And we will handle in this video case 10 of this element. The orange color means simply supported. The green color means continuous slab or fixed into a wall. So we are now with case 10. It's about a two-way concrete slab with a hole tracking yield lines, not necessarily centric, but a hole tracking yield lines. So we look at the slab, and there is a reservation in the slab with a size D1 and D2, and the position of the slab is given by D3, D4, D5, and D6. So it's a hole which can occur over the whole slab. There is of course, the relationship that D4 plus D2 plus D6 must be equal to B, and D3, D1, and D5 must be equal to A, of course. We draw the yield lines. We are using here in this case 10 tracking yield lines. That means that the yield line goes from the support to the corner of the reservation. We are not using the 60-30 rule because in this case it will not be realistic. So we only consider this is case 10. And the conditions of case 10, of course, there is also a yield line at the fixed end. And the conditions are that it's a two-way slab and the maximum hole size, of course, but also that for the position that D1 plus D3 must be smaller than A. That's obvious. And D2 plus D4 must be smaller than B. And then, like I said before, we have the relationship between A, B, and the D1, D2, D3, D4, D5, and D6. Now let's see what to visualize it. What are those conditions? What does it give? So an example is, for instance, this. You can now place this also on the left-hand side. You can turn it around. And so you see that you have all different possible positions of the reservation. You see immediately this is strange because I'm coming too close to the edge to have a yield line like that. It's not necessarily possible. So that's why we stay a little bit away from the fixed end. So let's see how we calculate it. The energy or the work done, let's put it this way, the work done by the external forces are then equal to, we take all the green portions, which are the triangles. So for the three portions, it's simple. It's, for instance, D3 times D4, D3 times D4, then D4 times D5. So it's the surface of the green elements, which consists out of triangles. So the mean deflection is delta over 3. Then we look at the orange elements, which are rectangulars. So it's also very simple. It's D3 times D2 and so on. So this is very straightforward, and the mean deflection is delta over 2. So that's very easy. Then the work done by the internal forces, it's also straightforward. You have the yield line. You make a projection to the axis of rotation. So you have D4, and the rotation is delta over D3. So now you can do it for each yield line. You make a projection in this direction and in that direction. So you have 8. 1, 2, 3, 4, 5, 6, 7, 8. So this, and then you are left with one yield line, which is at the fixed support. So the length is B, and the deflection is delta over D3. Not the deflection, but the rotation angle is delta over D3. Now, when you fill in all those variables, then you will have a formula which is not very handy. to write down. So we'll keep this notation here. The bending moment then is when D is equal to E. You find that then M is Q EX times DX, and EX is equal to E divided by Q delta, and DX is equal to D divided by M delta. So with this geometrical expressions. Bearing capacity is then 100 M0 divided by M, and M0 is a bearing capacity without the hole. Let's give an example how we can go on with that. We have a slab with dimensions 9 and 6 meters, and there is a reservation in it, and this reservation is positioned like it is mentioned on the drawing. We draw the yield lines. In the case 10 of attracting yield lines, so it's very simple from corner to corner, and of course there. The depth of the slab is 250, the concrete cover 30, floor finish 1 kilonewton per square meter, a mobile load of 10 kilonewton per square meter, and what is the needed reinforcement. First, we calculate the load in ultimate limit state. It's 1.35 the permanent load plus 1.5 times the mobile load gives you 24.79 kilonewton per square meter. The different parameters now are there, and it's from the previous slide. The maximum bending moment is then bending moment times the load times EX over DX. We fill in all those parameters in the formula that was given on the previous slide, and you find 37.54 kilonewton meter per meter. The lever arm in X direction is the depth of the slab minus the concrete cover, minus the diameter, minus the point of gravity of the reinforcement in that layer. So there's only one layer in the X direction. So it's 8 divided by 2. The 8, we take the smallest diameter. It's just a guess. Maybe we should use later on 10, and then we redo the calculation. So the lever arm is 216. The lever arm in the other direction, second layer reinforcement in the other direction. That's why this is coming there. It's 208. And the mean lever arm is 212 millimeters. So the needed reinforcement is the bending moment divided by the lever arm and the yield strength of the steel, and augmented by 10% because we are in a per bound situation. So the reinforcement is something like 500 square millimeters per meter, and that gives you a diameter 8, 10 per meter. You can also put a diameter 10, but this looks very nice. So this slab must have reinforcement of diameter 8 every 100 millimeters, this in X and Y direction, top and bottom. Now, we can, for this particular case, make a graph of the bearing capacity in function of alpha 4. And it means that we have a slab with geometry 1.5, so B is 1.5a. The reservation is always 0.1 times 0.2, and the distance from the upper edge, which is D3, is 0.6, and this is alpha 4, or it's the position of the hole. So now you can see that in this situation, you will see the hole will move from there to there, and the hole is fixed in dimensions, but not in position. Only the vertical position is fixed by D3. You will see here we have, there we have 100%. Then the next point, we have 88%, and then we have again 100%. So this goes from 100% to 88 to 100%, which is exactly this curve. Okay, so in fact, it's almost between those two, between, for instance, 0.25 and 0.85, you will lose bearing capacity, and otherwise it will stay the same. Now, what we have seen, we see that the position of the yield lines, we have chosen the 60-45-30 rule, but in fact you should optimize it. You should make an angle alpha, and you should optimize the alpha to have the maximum bending moment. But for a normal slab with no particular special things, the 60-45 and 30 rule is okay. But for reservations and slabs, there's something which is more difficult. So the first one is with the 60-45-30 rule, and this is the normal yield lines that you can expect without a hole. And when we make a hole like that in it, then those yield lines disappear. But now you will see this yield line comes on the side of the hole. This is okay. This is also a yield line on the side of the hole. In reality, there will be a yield line from the corner going to this corner and from there going to there. So it's a mix of yield lines. We are not sure that the pattern we have chosen with this rule is the correct one. Now, how will we choose them? Okay, let's do now an example. We have exactly the same slab with the same size and position of the reservation. I take yield lines by attraction and yield lines by the 60-45-30 rule. And we do the calculation for both. And we see that then the maximum bending moment is 1.58 times the load, and the bearing capacity is almost the same. It's 100.1%. So it means by making a hole like that in this slab, it will not lose bearing capacity. When we use attracting yield lines, you have 109% of the bearing capacity, and the bending moment is lower. It's 1.45 times Q. So this means that using yield lines by attraction, you have a more optimistic result. You have a more optimistic result because the bending moment is smaller. So by using attracting yield lines, it gives you more capacity. So you must be careful when you are using this yield lines by attraction that you are not on the safe side. Not always. You see here there is a 10% difference. This is because this reservation is close to the edge. So be careful by choosing attracting yield lines or the 60-45-30 rule.